In this section of M.2.2, we're going to evaluate the information in tables, charts, and graphs using statistics. I want you to go over here and look at your objectives for this section. Then I want you to look at the key terms. We're going to discuss the key terms in depth as we actually work through these sections. But for the TEAS test, what we want you to make sure that you understand is that the TEAS test will require you to understand some basic concepts and carry out basic statistical calculations. The internet is a good resource for glossary term definitions, additional explanations, and practice problems. I've got a practice problem at the end that's very similar to what you may see on the TEAS test. It's also what you're going to see in real life. But one of the first things we're going to talk about is calculate measures of central tendencies. Mean, median, and mode. As you can see down here, here's the definitions for each one. We're also going to talk about the range. So what I want you to do is I want you to stop this video and I want you to read these 4 paragraphs in full so that you understand how to find each one of these. And on the lecture notes that's posted in Canvas, I've also gotten written out how to find each one of these. This is what described in those 4 paragraphs that I told you to read. The measures of central tendencies include mean, median, and mode, and you should already be familiar with these concepts, but if you're not, this is going to tell you exactly how to find each one of them. To find the mean of a list of numbers is the average of the list. So what you're going to do is you add all the numbers together in the list, then divide that sum by the number of items in the list. To find the median of a list of numbers is the middle number in an ordered list. Now it's very important that if the list is not in order, you put the list of numbers in numerical order from smallest to largest first before you start doing anything else. Then there's a little hint. If there's an odd number of items or terms or numbers in your list, there will be one middle term as the median. If there's an even number of terms, there's going to be 2 middle numbers. So find the average of these 2 middle numbers to be the median of the list. So an example would be if I had 7 items in my list, there would be one middle term. It's going to be the 4th number because you got 1, 2, 3. Then you got 7, 6, 5, then 4 is in the middle. If there's 8, there's going to be 2 middle terms, the 4th and the 5th numbers. So you would add those 4th and 5th numbers together, find the average of those 2 numbers, and that will be your median. So there may be a little work based on the number of items in your list. Now the mode is the easiest to find, but it's the one that is most missed if it's asked as a question. Here's the reason for it. It is a number or numbers that occur the most often in a list. So you can have no mode if all numbers are listed the same number of times. So if I had 1, 2, 3, 4, 5 as my numbers in my list, each one of those are listed only one time. There's no number listed more than any of the other numbers, so there will be no mode. You can also have just one number as the mode. If it occurs more often than any other number in the list, and no other number occurs the same number of times or more than it, then you just have that one number. You can also have multiple modes. If 2 or more numbers occur the same amount of times in the list, but still more than all the others. So it's very important you understand it is the most listed or most often number in the list. So if all numbers are listed the same, it's no mode. If only one number is listed more than the others, it's one number. If you have multiple numbers that are listed the same number of times, but still more than any others, you can have multiple modes. And the range of a set of data or numbers is found by subtracting the minimum value from the maximum value. So you know how far apart the lowest and the highest values are in your list. It is also very important that you talk about the shape of the data distribution can reveal valuable information and can be described by the following characteristics. Symmetry is when graphed a symmetric distribution can be divided at the center with each half mirroring the other. So if I went to the center of this graph, drew a straight line up and down, and looked at both halves, they would look like they were mirror images of each other. That would mean it was symmetric. You can also look at a graph, that's what they call bimodal. That means it has 2 different peaks. I have a peak here, and then I have a peak here on my distribution. It's called bimodal. If you only have one peak, like the example up here, this is called unimodal. You can also have what we call bell-shaped unimodal. That means there's one peak, and if I again drew a straight line down through the center here and looked at each half, they're kind of mirror images of it. It's kind of like a bell-shaped curve in another math class that you may have heard about. You also have what we call skewness. In skewness, when you have most of your values at the lower side and very few at the higher side, then that's what we call skewed right, because most of your numbers are at the lower side and have very few at the higher side. The opposite will be if you had very few low values, and then all of a sudden you started getting a bunch at the higher level. This would be skewed left. So it's kind of like the name is the opposite of what it is. More at the left means it's skewed right. More at the right means it's skewed left. You can also have what we call normal distribution or uniform distribution. That's when it has the same number of values all the way across your list, kind of like in this example here. Instead of having actually the graphs or the distributions like we talked about right here, we can have the data table, or we can actually have a graph like we talked about in the last section. This can also help you determine the trend. Sometimes it's easy, sometimes it's more difficult. So what I want you to do is I want you to stop the video, go ahead and read these 3 paragraphs here to help you understand what this table is talking about. If we look at the data table, we can see that the lowest value has a certain number, and then it starts going up as our X increases, our Y increases. But then when we get to a certain point of 5.0, it starts as the X gets higher, the Y starts going down. So this is one of those where it's going to be kind of going up, goes to a point, and then comes kind of down. This is what you see in the graph here. We can see that the trend will be, starts out low, goes up to a point, and then starts coming back down after it meets that point till it gets to the very end. So data trends can be seen with data tables or data graphs on some, but not all. The more difficult ones, where you got a large data table, it may not be as easy to see this kind of trend. Now, one of the last things we're going to talk about in this section here is the data set modules can reveal what is known as expected values as well as outliers. If you can look in your book, it's a little bit better than on my screen here, but there is a trend line drawn from the top down to the bottom. It's kind of a curve, it's not a straight line. But if you can see that trend line in your book, you can kind of see that most of the values are right around that trend line, either above or just below. They're kind of close to it, maybe not exactly right on it. But then all of a sudden we found this one way out here off, way off the trend line. This is our outlier. This is a value. It's not what will be considered to be a normal expected value. That's what an outlier means. It's not normal. It's unexpected. And as you can read down here, it says all points in the graph are fairly close to the trend curve except the one that is way above the rest of the data. Visually, we can qualify this point as an outlier or unexpected value. All the other data points follow the same trend and thus are expected values. And you can see this a lot of times on different graphs based on what you're trying to show a trend for. Most of them should occur right around the trend line, but then again, you may have some that are way off. Now this ends this section, but what I've done is I've worked out a problem here in your practice problems. These are posted in Canvas, so go out there and see how to do each one of these problems. The first one says find the mean, median, and mode of the following data list. I've worked out an example I'm going to show you on this video of doing the same thing. Let's look at this example of central tendencies. A normal resting heart rate for adults ranges from 60 to 100 beats a minute. And what we did was we took the pulse rates for 15 different students and got them listed each one of here. Now you can see this list is not in order from smallest to largest. It's just randomly listed the 15 students. As we took each one's pulse rates, we just wrote them down one at a time. Now to find the mean of the list, we're not going to have to change anything. We just add up all those 15 different students' heart rates or pulse rates, found the sum, then divided by 15. So once I added all the pulse rates, I got 1,092. Going to divide by 15, I get a 72.8 as the mean. That's the average. Remember, the mean is the average. This is exactly the way you would find the average of your test grades if you were doing that. Now to find the median of the list, since it was not in order first, I got to put them in order first. So I went and found the smallest number was 61. Then our next one was 65, 66, all the way up to the very last one. And then I counted, we've got 15 students. That's an odd number. So we're going to have one middle number, which is the 8th number. What I did was I counted 1, 2, 3, 4, 5, 6, 7 from this side. Then I counted 1, 2, 3, 4, 5, 6, 7 from this side. And 71 was the middle number, the one in the very middle. This is the 8th number. So that's my median. Then come down here to find the mode. It's the most listed number or numbers in the list. So I had to go back up here, and it's easier if you got the ordered list. You can kind of see. Well, all these numbers here, until I get to 70, they were all listed once. So 70 I got listed twice. 71 I also have listed twice. And all the other numbers are listed only one time. So the most listed numbers are 70 and 71 because they're both listed twice and all the other numbers are only listed once. So my mode is 70 and 71. So I have two modes in this particular case. So be careful when you're finding the mode. It's the most listed number or numbers in the list. So now as you go back to do your practice problem, you now know how to do the mean, median, and mode. The second one says, which of the following best describes the distribution portrayed in the graph? Go back and look at each one of these and make sure you understand the definition. And you can see from this one, which of the following describes the trend of the data portrayed in the graph? It's kind of going from very high to then goes down to very low. So what kind of trend is that? It's a decreasing trend. It's not increasing. If it was increasing, it'd be going up. If it was stable, it'd just be straight across the line. If there's no trend, it'd be all, kind of a weird curved line. So make sure you understand what a trend is. Make sure you understand what a distribution is. Then make sure you should understand how to find the mean, median, and mode. And we didn't find the range of our example. We could have easily found that. We would just took the lowest pulse rate and the highest pulse rate and subtracted them. That would have found me my range. So we didn't do that on our example, but you could do that on your problems. So hopefully everything is talked about in this particular section you'll understand. But if not, just shoot me an email.